Critical points. So critical points are the points on the curve where either of these things happen. Either the derivative is equal to 0, so the stationary points that we just talked about, or the derivative is undefined. So these are key points on a curve. So what sort of ones could we have? Well, these are the ones we just talked about. We could have a maximum. That's where the derivative equals 0. We could have a minimum where the derivative equals 0. Both types of critical points. We tend to call those ones stationary points. It's sort of like, a square is a rectangle, but we don't call it a rectangle, we call it a square. It's the same sort of thing. That there, very dodgily drawn, but that's meant to be what we call a horizontal point of inflection. So the curve inflects, that's where it changes concavity. So it's like the curve's twisted. And at that point, the tangent, theoretically, is horizontal. Maybe not. Theoretically, it's horizontal. A sideways parabola. The derivative would be undefined at that point because the tangent, if you were to draw it, would be vertical. And so the slope's infinite or undefined. Another type is something like this. It's what we call a cusp. It's undefined at that point because when you approach it from different directions, you don't get the same answer. So it's not what we call smooth continuous. It is continuous, there's no breaks, but it's not smooth. It's like it's got that sharp point to it, like an absolute value graph. That also is not smooth continuous. It's continuous, not smooth continuous. So that's what we call a cusp, and that's undefined. Okay.